Hello, my name is Ravana, and today we'll be discussing the central nervous system. The central nervous system is broken up into the sympathetic and the parasympathetic. So, starting off with the sympathetic nervous system, the short preganglionic fibers release ACH to activate the nicotinic receptors, and the long postganglionic fibers release norepinephrine, which binds to adrenergic receptors on the target organs. In the parasympathetic, the preganglionic fibers are long and release ACH once again to activate the nicotinic receptors. The short postganglionic fibers release ACH, which binds to the muscarinic receptors on the target organs. The key differences between the two is that the sympathetic uses norepinephrine for rapid responses, so this is going to be the fight or flight, while the parasympathetic uses ACH for the routine maintenance. So this is going to be the rest and digest functions. So the anatomy of the neurons, I first want to talk about the cell bodies and the ganglia. So the preganglionic and the cell body neurons are in the spinal cord in the brainstem, while autonomic ganglia are positioned outside of the central nervous system. And the sympathetic ganglia are typically located near the spinal cord, while parasympathetic ganglia are closer to or within the target organs themselves. So as you can tell, there are differences between the preganglionic fibers in the sympathetic nervous system and in the parasympathetic nervous system. So one is shorter and one is longer in the parasympathetic and the sympathetic nervous system. So preganglionic fibers themselves originate in the central nervous system and release acetylcholine to activate the postganglionic neurons. The postganglionic fibers extend to the effector organs and can replace ACH or norepinephrine depending on the division and where they are. At the bottom of the sympathetic neuron, you can see that there is something called an adrenergic fiber. There's also something called the cholinergic fiber, and there are differences between the two. So in the adrenergic fibers, these release norepinephrine and include most postganglionic fibers of the sympathetic nervous system, versus the cholinergic fibers, which release ACH, and those include preganglionic fibers and postganglionic fibers of the parasympathetic nervous system. So both of these are in two different nervous systems, so that's the big difference between the two. So there are different roles in the neurotransmitter in the sympathetic and parasympathetic activity. So in the sympathetic nervous system, norepinephrine and epinephrine stimulate the fight or flight responses. This enhances an individual's alertness and energy. In the parasympathetic nervous system, acetylcholine, which is ACH, promotes the rest and digest functions, as I mentioned previously, which maintain the routine bodily processes as like urinating or simple digestion of our food. So there are types of effectors, which these are going to be like the target organs, which include smooth muscle, cardiac muscle, or glands. There's also a thing called alpha and beta receptors. So an example of an alpha receptor are vasoconstriction in peripheral blood vessels, and beta receptors is vasodilation in coronary arteries and bronchodilation in the lungs. In dual innervation, many organs receive input from both the sympathetic and the parasympathetic nervous system. So, an example of this is heart rate regulation. So, the sympathetic nervous system increases while the parasympathetic nervous system decreases. So, an example of this could be like you're running, so your heart rate increases, and then once you slow down and do your cool down lap, your heart rate starts to go down. The overall function of the nervous system is to maintain homeostasis. So as I mentioned previously, a good example of this is during exercise. So during exercise, the sympathetic nervous system increases the heart rate and redistributes the blood to the muscles, while the parasympathetic maintains the baseline functions. In the previous slide, we discussed the neuron side of the parasympathetic and sympathetic nervous system. So now we're going to discuss the effectors. So the neurons in the sympathetic nervous system originate in the thoracolumnar spinal cord. So this would be T1 through L2, and the parasympathetic neurons originate in the brainstem. So this is going to be like cranial nerves and sacral and in the spinal cord as well, but it'll be S2 and S4. So there are different responses on both sides of the parasympathetic and sympathetic nervous system. So in the sympathetic nervous system, our heart rate and blood pressure increases, and bronchodilation helps improve our oxygen delivery. We reduce our digestion and our urinary activity to conserve our energy in the sympathetic nervous system. So an example of this is preparing our body for a rapid action during stress. So the sympathetic nervous system contributes to our fight or flight responses in the body. So parasympathetic responses would be a decreased heart rate and blood pressure, and our digestion is enhanced and our nutrition is easier to absorb. Parasympathetic also promotes relaxation and energy conservation. So an important piece of this is facilitating our recovery. So for example, slowing down during our run and stretching after our run helps us maintain routine functions. So this is going to be the rest and digest part of our central nervous system. So this contributes to our homeostasis because the autonomic responses ensure balance between energy and conservation of our energy. So during sleep, the parasympathetic dominance supports repair and growth, while the sympathetic activity is minimized to conserve our energy for the next day.